Hey there, I'm Jackson with Systems Foundry. If you're anything like me, rewriting boilerplate code over and over again can really affect your productivity and creativity when you're writing code. I know for me, when I have to write some boring code to get something working, I'm often less interested in trying something new because it would take so long to make something basic work. This is especially true in Go, which is the backend language that I tend to reach for. Go is very famously verbose, requiring you to write a lot of code to do a simple thing. That's why I wrote my own Go library called Pilot. It handles a lot of basic HTTP application stuff that you'd expect, like routing, JSON validation, and more. It even wraps Go's SQL.database struct to help maintain database connections in all of your routes. It uses Go routines so it can scale up as much as you need it, and it's still simple and easy to work with and develop more things quickly. I'd love to show it to you in this demo project. Let's get started. Here, we're in a brand new Go project. The first thing we're gonna have to do is add the pilot dependency, which we're gonna do with the go get command. Perfect, we've added pilot. Now, Pilot expects a database. You can't use Pilot without one. So we're gonna go ahead and just add a SQLite database for a local file-based access. Perfect, all our dependencies are here. This is all we need to get going. We're in our main.go file, and we're gonna start by adding our main function and our imports to scaffold a basic server. Let me explain to you what I just did. So we're gonna declare a type app state struct. Now, Pilot has this concept of route state, and this is state of the request. So for example, if you were passing around some sort of authorization header, you can parse that data ahead of time and store it in your app state. Middleware functions have the opportunity to write to this state, and then you'll get the final version in your route handler where you can do whatever you need with it. And like I said, it's helpful for if you, for example, your middleware requires authentication, you can then store that authentication result so you don't have to look it up again later, resulting in lower latency and less database reads. In our main function, we start by declaring a database. We're gonna use the SQLite 3 driver with just a local file. If there's an error when opening a SQLite file, something has gone very tragically wrong and we shouldn't even start the application. Next, we'll actually initialize our application on port 3000, giving it access to our database, and we'll call app.start. So now if we go ahead and run our application, we're gonna see the starting server on port 3000 message. We're gonna get the registered routes, which right now is empty because we haven't registered any routes. And you'll see all of our workers have come online. The amount of workers is controllable by you. It defaults to 10, but you can easily scale it up further. And in a production environment, you definitely should be scaling it further. Now let's go ahead and add a simple hello world route. Basically, we're gonna set it up so if you make a GET request to the root of the application, we're just gonna return the string hello world. We'll build on it in a little bit, but I wanna show you just how easy it is to add a basic route. So this is what a route handler looks like in Pilot. It's pretty straightforward. It takes in a route request specialized to your request state type and returns a pointer to an HTTP response. Now you can manually initialize a HTTP response, but there's a lot of helper functions built into Pilot to help you return HTTP responses in one line. Right here, we're using the string response, which returns a 200 OK HTTP response with the text that you specify. That's the function. Now all we have to do is register it in our application. Perfect. Now we have our route set up. You can see it's one line to register our route. app.routes.addRoute. We specify the type of route it is. In this case, a GET. We use just a slash for the root, and we pass the function that we'd like to handle the request. There are ways to scope your requests a little bit more called route groups, but it's kind of an advanced topic and I'm not going to go into that in this video. If you're interested, check out the documentation on route group. You'll find what you need there. Now, if we go ahead and run our application, we're going to get the same message we got before, starting server on port 3000, but we're going to notice that registered route now at the root. Now we can use our HTTP request tool to make a request to our server and we'll get that text back. So let's go ahead and make that request. Perfect. We've made a request to get slash and we are getting the text hello world back. Let's say we get a little fancier. We're gonna accept a query string from the user, that's their name, and we're gonna use it to greet them directly instead of a generic hello world. It's not that much more code to do, and let's see how we can do it now. Okay, so we've implemented this. You can see it's only an extra 4 lines of code. The first thing we do is we use the query get string function. What that's gonna do is try and read a query string and it will return a pointer to that value. If there's nothing, that pointer will be nil and we can return a bad request response. Bad request response is a function in Pilot that helps you craft a 400 error message. HTTP error code 400 is bad request, and it tells the client that, hey, you've sent us data that we don't really know how to parse. You need to send us better data. In addition, it returns the error message provided in the argument. So that way, the client knows what they need to do to correct this issue. Let's go ahead and try it out now. If we make a request to the root path without providing a name query param, we're gonna get an error. Status false, message, name is a required parameter. This is very helpful because if I'm consuming this API, now I know exactly what I need to provide to correct this error. Let's go ahead and provide a name. Now that I've sent data in the proper format, when I send this, I now get the proper response, hello Jackson. That's how easy it is to read data from a query string. It's safe too, as we just demonstrated. If we don't provide it, we get an error and our function exits early. This makes it easy to write safe routes where we can error check without being too verbose. Let's go ahead and kick it up a notch. Let's take advantage of the database integration that Pilot supports by making a log of every user who visits our website. To do this, it only takes 5 lines of code. Let me show you how. Okay, so in our main function, we want to make sure that we have our table set up so we can insert data. We're going to do a create table if not exists visitor, and that's going to be a table just to store the log of every visitor. We're going to give it a primary key, a name, and a timestamp, which will just be a Unix timestamp. If there's an error, we will panic because that means our application can't function. So we can just panic. This isn't something that we're going to really be able to recover from, so we'll just crash the process. Next, in our route function, we're going to perform a basic SQL insert, and we're just going to check to make sure that the data is successfully saved. If not, we will return the error message response. Now, error message response, just like bad request response, returns a HTTP code, but this time 500, which indicates a server error with the message we provided. Because SQL errors can often leak information about the database schema, which we don't want to do to any public-facing service, we're going to return a generic error message if that happens. If everything is successful, we'll return the exact same message that the user has been getting before. Let's go ahead and try it out. So again, we're going to make a GET request to the root with my name. We've gotten the hello Jackson message again. Let's go ahead and check our database. And you can see we have the record we expected right in our database. It only took 4 lines of code in our main and 5 in our route handler to add basic database insert support. This is the goal of the library, to make it easy to do common tasks by abstracting some of the stuff away and providing convenient functions to do common things. Let's do one more thing. One thing that can really be a pain is validation. Go has built-in JSON functionality, but it doesn't provide validation on a per field level. So that's why I've integrated this into Pilot. For our next trick, we're going to accept a post request to the root, and the user will be able to provide a name, and we'll use that name to filter and select from our database and try and pull names that match the name that the user has provided. To do that, we're going to accept a JSON body with the format of a name key with a string value. You're going to see we can validate this schema and provide rich error messages if we don't get what we expect. The first thing we're going to do is write a struct called nameSearch with one field name. That's going to mirror the schema that we're expecting. The next thing is to write a function that actually parses this data. So this is the function here. We're going to instantiate a pilot.json object. We're going to try and read in the data we've received. If the error is not nil, we'll return that error. We'll try and read the name. If the name exists, then we'll set it. Otherwise, we're going to return an error. And if everything has gone right, we'll return a valid nameSearch struct. Note that the error is very informative, containing helpful error messages on how to rectify the error, including the key path where it occurred. If the data type is incorrect, it'll say we expected a string but didn't get one. And it's very in-depth and will help your users understand what went wrong. The final thing to do is write the route that actually receives this data and searches the database for the name that's been provided. All right, so I wrote that function that we're going to need, and I registered it as a post route to the root. Let's go ahead and look at this function. The first thing we're going to do is attempt to read that JSON body with that function we wrote. It'll either return the query data or the error. If the error is not nil, we're going to return a validation error response. This is the similar thing to bad request response. In fact, it's the same thing, except for it accepts an error and returns the string value of that error. The next thing we're going to do is we're going to run a database select statement. We're going to select only the name column from the visitor table where name is the name that's been requested. We'll do some basic error checking. We're going to read in all of the names that we got. which if it matches will be just one, but this is just an example. And then if everything has gone right, we're gonna do pilot.json response with our array of strings. Pilot.json response uses Go's built-in JSON support, so you don't have to do anything special to return an array of strings. Let's go ahead and run this again. This time, when we start our server, we're gonna get the registered routes route, and it's gonna have a get and a post route. This lets us know that our route was registered successfully. Let's go ahead and run this request without any data at first. So we're gonna uncheck this and let's go ahead and run this request without any data. If everything has gone correct, we should expect a validation error saying field name is required. And this is just what we expected. We get the error field name is required. Let's go ahead and put this key in with name Tim, so we shouldn't get anything. And perfect, we don't get anything, but we do get a valid empty JSON array. Now, if we put in my name, Jackson, we get that one row that we were looking for. So that's all it takes to build something very straightforward with Pilot. Now, there are definitely some pain points, especially writing that JSON parsing function. I'm working on a tool to help automate that, but even at this stage, I'm still happy to write that code because it means I don't have to type out long, complicated error messages by hand. It's automatically made by the framework. So yeah, that's Pilot. Thanks so much for watching this video. I hope you got something out of it, and I hope you go and take Pilot for a spin. I created Pilot because I really was frustrated with how much boilerplate there was to make a HTTP server in Go. So if you find yourself frustrated by the same thing, please check it out, star it, file a PR. I'd love to see your thoughts on that. Thanks for watching the video. Thanks for sticking around. If you enjoyed the video, I'd really appreciate it if you would thumbs this video up. Thanks so much for watching. Until next time, happy coding.